Hi everyone, in this demo, we will show a RIVE solution for IPsec inline acceleration using FPGA-based SmartNIC. This is the server that we will be using for this demo. It has 2 Intel Xeon on 2 sockets, 20 physical cores on its CPU, 256GB RAM, OS is Ubuntu 16.4 LTS. We use 2 Intel mapped 80 cards, which is the prototype version of PAC M3000 cards for our IPsec acceleration. We also use Intel 40GB NIC cards, not as a part of the acceleration data path, but only for performance comparison purpose. Features that we are going to show are AES 1-to-8 GCM with ESP tunneling, 8 by 10 gig ports to make 80 gig IPsec throughput at layer 1, 256 flows running on 8 ports, DPDK-based allocations, VBB, which is Cisco Vector Packet Processing, T-Rex, which is Cisco Traffic Generator. On the screen now is the demo scenario. T-Rex ports and VBP ports are connected back to back. All of ESP packets are encrypted, decrypted by hardware. T-Rex generates 80GB ESP encrypted traffic to VBB. VBB takes decrypted ESP packets, extract plaintext IP, then does ESP encapsulation to send to T-Rex. T-Rex receives packets, calculate throughput, drop rate, etc. And to show the advantages of hardware over software solution, at VBB side, we will replace the FPGA cards by 2 Intel NICs. AES-NI GCM crypto device will be used for packet encryption. We will still keep FPGA cards at T-Rex side to generate maximum 80GB ESP traffic. We will first see throughput of software-based IPsec solution with AES-NI, then move to hardware-based so that we can see the advantages of hardware solution. GCM 1-to-8 will be used. One CPU core is assigned to each port. Current screen is the physical connection between FPGA card and Intel NIC. Now we start T-Rex, VBB, and T-Rex UI. After started, you will see the screen like this. Next is to open T-Rex UI and apply the configuration for 256 byte packet size. You can see with plaintext packet size 256 bytes. Using software-based solution, we can only reach maximum 30 gig, which is very far from 80 gig. Similarly, for 512 packet size, throughput is only 44 gig. And 59 gig for 1K. Now, let's move to a RIVE IPsec hardware solution. This picture shows the physical connection with 2 FPGA cards. Then we start the configuration with 256 bytes with the IPsec uploaded to FPGA card. Here's the throughput result. We can see throughput is 79 gig, which is very close to 80 gig or light rate compared with 30 gig when we run with software solution. And with packet size greater than 256, we can easily reach 80 gig. For example, this is the result with 512 bytes. It's 80 gig. Next, we will show the CPU utilization between with and without IPsec acceleration. This chart gives a full throughput comparison between software and hardware-based solutions, with different number of cores assigned to each port. The yellow part is for writing-only case with no IPsec, for the purpose of showing max throughput of a RIVE inline NIC-only function. With one core assigned to each 10 gig port, you can see a RIVE IPsec can reach 80 gig for packet size from 256 bytes, while software-based solution is far from that. With 2 cores assigned to each 10 gig port, plaintext packet size from 128 can reach 8 git with Arrival IPsec acceleration. Software-based solution can only hit 8 git with packet size from 1K. This figure is to show CPU cores utilization with small blank-test packet size. The left-hand side is maximum throughput can achieve, and the right-hand side is the maximum number of cores needed to achieve that. We can see with blank-test packet size 256 bytes, 8 cores can reach 8 git with hardware solution, and that of software-based is just 56 git. Even when we increase number of cores assigned to each port, for blank-test packet size 128 bytes, Arrival IPsec hardware can hit 8 git if 2 cores are assigned to each port, while software-based just can hit maximum 41, even when we increase number of cores. That's all for the demo. Thank you for watching.